Dear students, now we are going to discuss about maximum signal to interference ratio. So this maximum signal to interference ratio, the very important technique in smart antennas. So what is this MSIR ratio? Otherwise, maximum signal to interference ratio technique means here we need to adjust the antenna array weight such that the power of the desired signal is maximized relative to the power of interfering signal. So here we are adjusting the antenna array weight depend on the power. For example, if you streaming the video, the power of the signal is different. The same thing, if you want to send the information through the text or voice means that power will be different. So based on that we need to adjust the antenna array weights. So now the working principles. See here the smart antennas, the first it will be receiving the signal from multiple direction and it will do the desired and interfering signal array from different angles. And the second thing it will be choosing the antenna weight. And the fourth thing it will be steer the main beam toward the desired angle. And the next thing it will be avoiding the interference by create the nulls in the direction of interference. The creating the nulls is nothing but we are reducing the side lobes value. And the next thing here the algorithm, this MSIR algorithm is focused only on signal and interfering, often ignoring the noise. So these are the working principle of MSIR technique. So now see here, this is the mathematical formulation for the signal to interference ratio. So you see here, this is very important, this formula. So W power H RS into W divided by WH into RIW. Here this W, the small w indicate the complex weight vector, and RS is the covariance matrix of the desired signal and RA is the covariance matrix of the interference. So we should know what are the interferences there for that particular signal and what we need to steer. The second thing is we are denoting no W power H. That H is nothing but Hermitian transpose of your weight vector. So here this optimal weight vector is obtained by solving the eigenvalue problem. That means we need to do the Hermitian transpose matrix for that particular weight. So based on that only we can find the maximum signal to interference ratio. Now see here. So this is one interference ratio index and that real time application. You might see that. So here you can notify from index 1, index 2, index 3, index 4. So like that it is there. So in that below that see here the first thing while you are addressing the small cell, the victim is macro cell. So what is the interference type? See here we are denoting the symbol red and dotted green and that solid green. So based on that, here the transmission mode we are indicating for this red line it is uplink and the green line for downlink. So you might understood uplink means transmission, downlink means reception. So now wherever it causes the interference that will be indicating here. See this first thing the index one it will be first connected to small cell user equipment to macro cell base station. So this is the first thing. So now like that we are see how much the indexes are crossing to that another station. For example, from the small UAE to this small cell BS station. So how it crossing. So this is the uplink the information. So that another example is also we are going to discuss. See here, you might have understood here very well. So now your desired signal is this red indicating, but you need to adjust the cell interference. The cell is nothing but so each cell containing one base station. So you might understood this thing. So this is the first cell and the second cell. So each cell containing one base station. So now how they are adjust this interference. See, so you need to get your desired signal. They are adjusting one cell to another cell. The first interfering cell is here and the second interfering cell is here. That another example also here. See, you might understood here very well. So how the interference they are adjusting, based on that we can find the ratio. So your user equipment, the blue cell, you might understood the blue cell. See here, the equipment where it present and the red cell where it present. How they are adjust the interference between the cell. So based on that only that formula we are using no, this SAR ratio. So here they will based on the covariance matrix of desired signal, matrix of interference. They are calculate the weight vector. So that thing only based on that only here they are adjusting adjacent cell interference. Similarly, these things also. So how much cells they are adjusted that will be showing in that above and below. So what are the main application of this signal to noise ratio? Is the first thing is adaptive beamforming, and second thing interference limited wireless network, and the third thing is cellular base station. It is very helpful. For that only nowadays we are enjoying the seamless connection. Thank you.